Good morning, and you're welcome to this morning's webinar. My name is Mark Gibson, and I'm Program Manager for the Teagasc Connected program. I hope you're keeping well this morning. This is the 7th in our series of Teagasc Connected Signpost webinars, which takes a closer look at science, policy, and advice around farm sustainability. The series is being delivered in association with the National Rural Network, Dairy Sustainability Ireland, and Food Drink Ireland, SkillNet. We want this session to be as interactive as possible, so we encourage you to use the Q&A tab at the bottom of your screen so that you can ask questions during the presentation, or indeed if you wish to ask them at the end. Also, this webinar is being recorded and will be available on the Teagasc YouTube channel afterwards, as well as the actual presentation itself. So today's topic will be looking at the efficiency factors around slurry. Slurry is an important resource produced by the livestock sector in Ireland. Properly managed, it acts as a vital nutrient that fuels growth. However, poor management can lead to losses to the environment and ultimately losses in profitability. To talk more on this, I'm joined by two Teagasc experts in the field of soil nutrition, Dr. David Wall and Mark Plunkett, who will be joining us shortly. David, you're very welcome to this morning's webinar. You can see us okay there?
Yes, thank you, Mark.
Great. So David, you're going to talk to us about slurry and how we can reduce emissions from slurry, both greenhouse gas emissions and ammonia, is that right?
Yes, a very important topic, and one of the key, I suppose, opportunities to reduce emissions on farm and to meet our national and EU targets.
I should mention also that we're joined by Pat Murphy, Program Manager for the Teagasc Environment Knowledge Transfer Program in Teagasc, and Pat's going to be helping us out with questions at the end of the presentation. So we're going to have two presentations today. First presentation from David. So David, I'm going to hand over to you, and you can fire up your presentation for us.
Okay, can everybody see that?
Yes, that looks good.
Yeah, so I'll just put it on present. So thank you very much, Mark, for the kind introduction. And as Mark said, we're going to discuss slurry use efficiency today and methods or opportunities to reduce both greenhouse gas emissions and ammonia emissions, but also other losses of nutrients from the soil to water and otherwise. So slurry is a very important resource on farms, and there's a huge opportunity to offset chemical fertilizer, so to enhance its fertilizer replacement value when you're applying slurry. So without further ado, we'll get into it. So just for context, the challenges, I know in the first and second seminar, Gary Lanigan dealt with some of the challenges in terms of emissions. In relation to slurry, probably one of the biggest losses of nitrogen is through ammonia volatilization when spreading. This is a national challenge for us. Agriculture accounts for up to 98% of the ammonia emissions as coming from agriculture. So that means then that agriculture has to take the responsibility, or shoulder most of the responsibility for meeting the targets. Those targets are a 1% reduction up to 2030, and then after 2030, we have a 5% reduction in ammonia emissions nationally to meet. However, ammonia mitigation can be both synergistic and antagonistic with greenhouse gas emissions, and I'll discuss that further in the presentation. So Ireland has got a relatively good deal in terms of reductions. There's other countries have up to 27%. However, they have other sources of ammonia production or emission other than agriculture, and it was deemed to be unfair in terms of penalising agriculture and food sustainability totally from an Irish context by having such a target. So ours is 5% reduction from 2030. So just to recap a little bit, in terms of the emissions profiles for both ammonia and greenhouse gas emissions. You can see in each of the pie charts there, there's many different areas in terms of where the emissions originate from. So from fertilizer, from manure, from grazing animals and hard standings. And then on the greenhouse gas side, again, enteric fermentation from the cows, from the soils as N2O, managed soils in particular, mineral soils, manure management again, limestone and urea. However, it's worth noting that in relation to slurry and manure management, approximately 3/4 of the emissions are related to manure management in some shape or form. And on the greenhouse gas side, there's a large proportion related to manure management, adding nitrogen to soils through manure management in the under storage conditions, and then manure management in terms of N2O, so methane and nitrous oxide. So this is very important in terms of what options or areas that we can identify with potential gaseous emissions mitigation. So the fact that we know this, we know where the emissions are originating from, means that it provides opportunities for us to look a little bit deeper in terms of research and also in terms of knowledge transfer on where farmers and agriculture in general can best engage here in terms of meeting emissions targets. So first and foremost, I deal with the ammonia MAC, so the marginal abatement cost curve for ammonia. Gary would have shown the MACs in the first presentation in this series. And as you can see here along the bottom axis, the x-axis, it's the potential tons of NH3, so ammonia, savings per year. So the wider the bar, the bigger the savings. And then on the y-axis, so the vertical axis, there you can see the cost. So where the cost is negative, it's beneficial, and where the cost is positive, it's costing the farmer to implement the measure. So there's cost beneficial and cost negative here. If we cut straight to the chase in terms of where manure comes in here in terms of ammonia management, we know that trailing hose, so low emission slurry spreading, so your band spreader type operation for dairy and other bovines are fairly significant, and there's a big opportunity there to reduce emissions. If we move further along there to the trailing shoe, again, you can see that the bars are wider, which means that there's more mitigation potential. And then also you have a small bar there in terms of pigs. The other areas in terms of opportunities for lowering emissions from manure management are altered timing for manure spreading. So spring spreading versus summer spreading. So summer spreading will have a higher emission because it's drier conditions, more sun, etc. And we'll discuss that a little bit further. And then slurry additives. So to amend the slurry during storage, so over the winter, to bind up that ammonium nitrate so that it's not lost later on during storage when you're agitating, but also when you're spreading later in the year. So those are the main areas. So you have your altered timing, you have additives during storage, and then at spreading you have low emission slurry spreading. If we look at potential management solutions for lowering ammonia emissions, and I have these ranked in terms of their ammonia abated. You can see there protected urea, so switching CAN to protected urea, or 50% of CAN to protected urea, has the largest mitigation potential or ammonia abated. Low emission slurry spreading comes in next, both for the dairy and for the non-dairy, at 2.7 and 1.7 kilotons of ammonia respectively. And then altered timing, so spreading in the spring rather than spreading in the summer, for both dairy and non-dairy slurry comes in next. If we look at all the measures or all the areas for improvement concerning slurry, you can see you have your low emission slurry spreading and altered timing, as I've discussed, covering slurry stores for pigs in particular, but also for overground cattle slurry stores. And then amendments or additives are also an option there to reduce emission, and we can get credit for all those. The other areas then are increased nitrogen use efficiency and reducing crude protein, both in pigs and in dairy rations. So the amount of protein that goes in, if it's higher, we end up with more nitrogen excretion out the back end of both pigs and bovines.
And David, if we look at the cost per measure or cost per kiloton of ammonia abated there, by far the timing, according to your previous graph, are the cheapest way of achieving that. Is that right?
Yes. So the timing is certainly cost beneficial. We increase nitrogen use efficiency by using the slurry earlier in the year because there's more grass growth, there's more demand for that nitrogen, and there's less losses. So it's actually beneficial for a farm to do that, and he can offset some of his expensive chemical fertilizer bill. The one issue with altered timing is verification on the farm. So it's not easily verified in terms of keeping a paper trail or keeping records of when slurry was spread. So in those audits, it's a measure that we would have concern over verification. But certainly from an agronomic standpoint, farmers should be practicing earlier spreading to enhance the use efficiency and to potentially offset chemical fertilizer. Okay.
Thanks for that, David.
Okay, so in terms of the greenhouse gas MAC, so our greenhouse gases are methane coming from the animals and coming from stored slurry, nitrous oxide coming from managed soils, so where you put nitrogen sources into soils, especially under wet conditions, they can be denitrified, and the gas is a greenhouse gas, nitrous oxide. And then thirdly is carbon dioxide. So carbon dioxide originating from soils and soil organic matter, from transport and diesel and power usage, etc. But by far the two bigger ones in agriculture are nitrous oxide from managed soils and methane emissions from bovines, from ruminant animals, should I say, and from slurry. So these are the two, I suppose, ones that we need to be concerned about, and we need to look for opportunities to reduce. So again, I've highlighted here with the red arrow, the low emission slurry spreading. Yes, it's costly. However, it provides a good deal of mitigation. Fertilizer type, obviously changing to protected urea, provides a big change there away from CAN. And then improving the efficiency of your dairy cows, dairy EBI, is also a big factor in there. So again, slurry amendments do appear here in terms of the greenhouse gas MAC. They have an opportunity to reduce ammonia emissions at spreading. And I'll just clarify that ammonia emissions, although we're not a greenhouse gas, are deposited back onto the soil and are a nitrogen source that can be denitrified. So we must reduce ammonia emissions to get the benefits from greenhouse gases as well. So again, I've summarized the potential mitigation management solutions. This is for lowering the agricultural emissions. So I haven't dealt with the land use change emissions, so such as forestry, etc. Or I haven't dealt with the power and fuel ones, but these are ones that are related to agricultural management of soils and of animals. And you can see there the soil and management mitigation options give a potential mitigation of over 1.2 megatons of CO2. In terms of ranking, protected urea is up there, draining wet mineral soils, Low emission slurry spreading is coming in third. Nitrogen use efficiency, obviously, and extended grazing, the inclusion of clover, and slurry amendments also appears here. So if we look at the two concerned with management of slurry, we can see there that they're significant, and it's low emission slurry spreading comes first, and then amendments or additives to slurry is the second one. Also, it must be noted at the bottom there, animal performance, including increased EBI, increased animal health, and increased genetic merit of the animals and feed use efficiency contribute a significant proportion to reducing emissions on farms as well. So just some of the science behind this. So losses from slurry, so nitrogen losses in particular, and ammonia losses, depend on soil and climatic conditions. So at the time of spreading, it's important to have suitable climatic conditions to minimize volatilization and nitrogen loss. So ammonia emissions increase in dry, sunny, windy weather. So if we think about when the majority of slurry was spread in the past, it was probably spread after first cut silage onto bare stubbles in the summer. This is probably the worst case scenario in terms of emissions, because you have no grass cover to protect the slurry, and you have dry soils with warm climatic conditions. The majority of N losses occur within 24 hours after application, so it's really important to have suitable weather at the time of application and for the following day. If we look at some of the science, the effective season on potential ammonia volatilization or nitrogen loss, you can see there on the x-axis, on the vertical axis, it's slurry nitrogen loss, the percentage of total ammonical nitrogen applied. And on the, on the y-axis, on the x-axis there, you have the months of the year. And these studies were conducted both in Ireland and abroad, and I'm summarizing these. And you can see there, typical slurry N losses are higher in summer. Just as I've said, the weather conditions are usually not suitable. They're conducive for higher losses. So we need to avoid or be very careful when we're spreading during this period of the year. And you can see there, the early part of the year, we get much lower losses. If we look at the science in terms of reducing ammonia losses using low emission slurry spreading, less. Slurry application method is what I'm showing here. Again, on the y-axis, we have ammonia losses, the percentage of total ammonical nitrogen applied. And then we have hours after application along the x-axis. And you can see there the dotted line for the trailing shoe, the low emission slurry spreading method, versus the splash plate. You can see there's a significant reduction, almost half the emissions with the low emission slurry spreading in total. However, it must be noted that these emissions are happening certainly within the first 24 hours, but probably within the first 6 to 12 hours. So the time at application is really important, and the weather conditions and method are also important. In this example, the trailing shoe reduced emissions by 36% compared to the splash plate on average. Work that was conducted at Johnstown Castle in County Wexford and a number of other sites. And if we look at other studies, total ammonia emission reduction of up to 65% were found in other studies using low emission slurry spreading. So the higher the loss potential the day that you're spreading, the bigger the reduction when you're using less. And then finally, nitrogen fertilizer replacement values, which is the important agronomic parameter. I have summarized 4 application methods. So the traditional splash plate method, the dribble bar or band spreader, the trailing shoe, which puts the slurry, parts of the grass and puts it down on the soil surface, and then shallow injection, which is not used very, very much in this country. However, it is used in other European countries, and it creates, the disc creates a shallow slit about an inch or so deep into the surface of the soil, and the slurry is injected into that. So again, it's reducing the surface area compared with the splash plate and the other two methods. If we look at the ammonia abatement, obviously the splash plate is your control treatment, so there's no ammonia abated. That's what we're comparing the others against. The band spreader or dribble bar reduces ammonia emissions by 30%, trailing shoe 60%, and shallow injection up to 70% on average. And if we look at the slurry availability at application there, we can see there you get 27% of the nitrogen that you're applying being available with a splash plate, and that grows to 35, 40, 43, and 46% with the three other methods, with the low emission methods. So you can see there's significant increase in slurry delivery and slurry availability for the crop or for the grassland. And if we think about it in terms of nitrogen savings, for 11 meters cubed of cattle slurry or 1,000 gallons of cattle slurry, you're getting 7 kilograms of nitrogen applied in that 1,000 gallons with the splash plate, 9 with the dribble bar, up to 11 with the trailing shoe, and 12 with the shallow injection. So we're almost doubling the nitrogen availability in the slurry as we go from the broadcast method, the splash plate, up to the shallow injection. And if we look at that in economic terms, in terms of being able to offset some of the chemical fertilizer, that's worth €6 for the splash plate. For the trailing shoe, it's €9.40, and up to €10.20 for the shallow injection in terms of the extra recovery of nitrogen. So again, well worth it in the economic terms, well worth it in terms of nitrogen use efficiency, and as well as getting the agricultural and agronomic efficiency, we're also getting reduced emissions and increased environmental performance. Finally,
we're going to have to ask you to speed through the last slide just to give Mark time to present his paper.
That's grand. So synergies and antagonisms are very important here. So we don't want to be pollution swapping by doing the best for one thing and then increasing the emissions on another emission. So ammonia versus greenhouse gases, reducing ammonia emissions will reduce indirect N2O emissions. So as I said, that ammonia is redeposited, it falls back down in rain onto the soil and is a source for N2O emissions. So you get the double benefit. Alter timing and technique for land spreading, so low emission slurry spreading and spring spreading of manures can increase direct N2O emissions. So again, by putting more nitrogen into the system, it's really important here that we subtract that nitrogen from our chemical nitrogen inputs. So we make a chemical nitrogen saving so that we become efficient. If not, we're putting out the same amount of nitrogen and we have more nitrogen present, so we increase the amount of nitrogen. Low emission slurry spreading and spring spreading of manures will reduce ammonia, but also total N2O emissions, so you get a double positive there. Reducing crude protein in the animal diet will reduce N2O emissions and ammonia. However, it has limited application where animals are at pasture. So again, we can't control where those excreta are deposited. And again, it's really important in terms of the slurry stored in the shed, but we need to manage what happens out in the field a little bit better as well. Slurry amendments or acidification added during manure storage will reduce both methane, greenhouse gases, and ammonia from slurry storage. So again, you get a benefit there in terms of using amendments. So that's it, Mark. I'll be happy to answer questions later on. After
we'll take questions just at the end of Mark Plunkett's presentation. So we're going to invite Mark to join us. Mark, can you hear us there?
Hello, Mark. Yes.
Yes, great. We'll get you to get your presentation up and running.
Okay, so I'm going to focus on all three major nutrients in terms of utilizing slurry on farm. So, like slurry, it's an organic, on-farm produced organic fertilizer, and it can effectively replace a portion of chemical fertilizers on farm. So when we buy fertilizer, we know what's in it in terms of NP and K. Like for example, we buy 18, 6, 12, 10, 10, 20, 07, 30. We know the level of NP and K in the fertilizer. So we need to think about, I suppose, slurry in the same light. We need to look at the fertilizer replacement value of slurry. So what I have in the table on the left-hand side there is that I have the available NP and K for typical cattle slurry at a dry matter of 6.3%. So there's a kilogram of available nitrogen, there's half a kilogram of phosphorus, and 3.5 kilograms of potassium, and they're all available nutrients. It's also important to consider factors that affect the nutrient content of slurry. Getting back to our bag of fertilizer, actually what's in it. So probably one of the biggest factors on farm there is actually dilution, the amount of water, like how much water is entering that slurry tank, say from milk washings or yard washings, and there can be a big variation in there affecting the NPK content of the slurry. We can measure slurry nutrient value on farm with something like a slurry hydrometer. It's just a matter of getting a sample of agitated slurry, dropping in the slurry hydrometer into a graduated cylinder of slurry, and measuring off the slurry dry matter. So if we look at the impact of dilution on the nutrient value of slurry, so as we go from a 2% dry matter up to a 7% dry matter, the nutrient content increases for NP and K. Like for example, if we take first cut silage, that gets 33 cubic meters of cattle slurry per hectare. If we use a 4% cattle slurry, we are under fertilizing that crop in terms of P and K to the tune of 40 to 50%. However, if we use a good quality slurry, like at 7% dry matter, we are supplying all the phosphorus and 120 kilograms of potassium. So my point here is that it's very, very important to fertilize your silage crop with a sufficient amount of P and K in order to get efficient use of that nitrogen that's in the slurry and also bag fertilizer in. Okay, to look a little bit closer at the nitrogen in slurry, there's a 50-50 split there between organic N, which is not fully available but becomes available during the growing season. What we're mainly interested in is the mineral N. Half of the mineral N is the same as urea N, it's ammonium N. Ammonia N, it's plant available during the growing season, but there is a risk of loss around time of application, as David has referred to. So things like timing of application, weather conditions, and application method have a big impact on the amount of ammonia recovered during and after application. Like the recovery for nitrogen can range from 15 to 40%. Like for example, if you take a splash plate with summer application, we're getting about 15% of the nitrogen recovered, while if we move to a trailing shoe with a spring application, we're getting about 40% of that nitrogen recovered. I suppose the next question that we need to ask, or in order to make the best use of cattle slurry, where should it be spread on the farm to utilize the NP and K in that slurry? So if we look at the nutrient profile of cattle slurry, 80% of the nutrient is actually P and K, and that's mainly potassium. So ideally that should go back to the silage ground. The slurry should be returned to the silage ground where it came from. So again, we look at soil analysis, take the fertilizer plan into account, and the crop that has the biggest demand for P and K on the farm, and that tends to be grass silage. It's also important to make the adjustment based on slurry dry matter, to ensure that we're maintaining the P and K balance in the silage areas on the farm. Okay, in terms of reducing nitrogen losses, probably one of the most important, I suppose, things is the time of application. So we're looking at a spring application, when there's the biggest demand for nutrients during the growing season, and especially nitrogen. We're talking March, April time as we're heading into peak grass growth. That's where we're going to get the maximum recovery of that nitrogen. Also, we'll have the weather conditions that are conducive to recovering, and reducing ammonia loss in that part of the growing season. Our target there is to have 75% of the slurry applied by the end of April. Also, weather is a big factor, especially with splash plate application, that weather conditions are all important. Like to reduce ammonia loss, we're looking at cool, damp, overcast, and even misty conditions. And that's what we generally get in the springtime of the year. So, you know, it is the greatest time of the year to utilize the nitrogen from a demand point of view, and also a recovery or reducing that ammonia loss. Again, we should avoid conditions like what we've had in the last, 6 to 8 weeks. You know, it's very warm, it's dry, bright sunny days. They are the conditions that are favorable to the loss of ammonia, especially with splash plate application. Like the trailing shoe or the low emission technologies sort of remove the weather element to a degree, or reduce the losses during say unfavorable conditions in terms of ammonia loss. Okay, if we move on to application techniques, so again, this is probably the most effective way to reduce ammonia loss, is both during and after application. Like if we take a splash plate and we're spreading a film of slurry, we're increasing the surface area and we increase the risk of ammonia loss to the atmosphere. Also, if we look at the nitrogen recovery, for a splash plate there, spring application, we're looking at 0.6 of a kilo per cubic meter. That's the amount of nitrogen that's recovered through splash plate application. If we move to something like a dribble bar, again, you have a boom on the back of the spreader, the slurry is piped out and you're reducing the surface area, and it's just dropped above the grass canopy. There's a significant reduction in ammonia emissions with the dribble bar or the band spreader. You're looking at about 30% reduction compared to the splash plate, and the figure there is about 0.8 kilo of N per cubic meter for slurry that's dribble barred in the springtime. If we look at the trailing shoe technology, so again, it's a slightly different piece of apparatus in terms of that you have a shoe fixed to a metal bar. There's downward pressure. The trailing shoe is getting very, very close to the ground. It's getting under the grass canopy, and it's very like it's very like the placement of fertilizer or the placement of slurry right in the zone where it needs to be utilized. And again, you're getting a further efficiency in terms of reducing ammonia emissions, increasing in recovery, and we're talking about a kilo of N per cubic meter. So again, it's a step up on the dribble bar and an improvement of about a 20% reduction in ammonia emissions with the trailing shoe. There's also other added, I suppose, benefits or advantages to the low emission technology. So again, you have less contamination compared to the splash plate. Also, you have a more precise distribution or application of nutrients across the spread width. And I suppose one of the big benefits there that over the last number of years is the increased flexibility. You can spread slurry into higher grass covers, without the contamination, and a quicker return to grazing with the likes of your band spreader or your trailing shoe. And also it's giving you a wider window of application, especially in the springtime when soil conditions, can be tricky. So you can pick the best time from a soil trafficability point of view. Okay, so if I just try to bring it all together in terms of fertilizer replacement value, or maximizing the nitrogen that's in that slurry in terms of providing more nitrogen in terms of grass production. So if we take the example where we've cattle slurry applied at 33 cubic meters per hectare by splash plate in the summer, compared to trailing shoe application in the springtime. So our summer application with the splash plate, we're only recovering 10 kilograms of that nitrogen, where if we move to a spring application with a trailing shoe, we're recovering 33 kilograms of nitrogen. So there's an extra 23 kilograms of nitrogen there to be recovered or made available for grass production, and that's worth about 20 euros per hectare. Another way of looking at it, I say this example here is for first cut silage. It has a requirement of about 100 to 125 kilograms of N per hectare. So we can supply a third of that crop's nitrogen requirement with cattle slurry. So there is a big savings there, both in terms of the need to purchase chemical fertilizer in the form of say urea or canned fertilizer, and also there's a savings there as well in terms of reduced fertilizer cost. Okay, so to pull it all together, so again, in terms of planning slurry applications and making decisions around how to use that slurry as efficiently as possible, both from a nitrogen point of view, a P and a K point of view, there's 4 questions we need to ask. The first question is, where do we apply it? So again, we apply it back to the silage ground. That's where it's come from. That's where there is the biggest demand for nutrients, and that's where we're going to get, I suppose, the most efficient use of the NP and K in that slurry. The second question we need to ask is, when do we apply it? And spring is best. The springtime of the year is the best time to apply that slurry in terms of utilizing the nitrogen and reducing the ammonia loss, and basically making more nitrogen available, to grow grass in the soil. The third question is, how do we apply it? So again, we're looking at a low emission technology, something like a band spreader or a trailing shoe. The technology has advanced and is advancing every day in terms of its workability and in terms of what it does in terms of placing that slurry, as close as possible to the target where it's needed for the grass to utilize it, and also to reduce the loss of ammonia through volatilization. And the final question then is basically the rate, or what's in my 1,000 gallons of slurry, or what's in my bag of fertilizer. And it can vary. You know what I mean? If it's low dry matter, it could be something like a 4,215, which is worth about €8 per 1,000 gallons, where a typical capital slurry is something like a 9,532, and it's worth about €25 per 1,000 gallons. Okay, Mark, that's
great, Mark. Thanks for the practical insight there. So we'll pull David in again, and we'll ask you to maybe stop sharing your screen if you can. Lots of excellent questions coming through here at the moment. So just while you're getting set up there, quite a few. David, can you hear me okay there?
Yes, yep.
David, a lot of questions coming in around the addition of biochar. Could you comment on that?
Okay, so there's been a lot of research done on biochar. So biochar is pyrolyzed plant material or organic matter, which increases its surface area and also increases its cation exchange capacity. So basically, biochar has a huge capacity to hold and retain nutrients. So in this context, biochar has the potential to bind ammonical nitrogen and phosphorus potentially in the soil. However, the practicalities of getting enough biochar to spread across a farm may be limited somewhat. So it's all right for smaller areas or for garden areas to improve the soil conditions if they were damaged previously. However, large-scale biochar production and application is probably not as practical.
Pat, you have some questions coming through there too?
Yeah, question for Dave from Harold Kingston. David, what time of year was the nitrogen abatement of the different spreading methods calculated? Remember seeing data showing spring splash rate equal to some or less.
So those are average across a 3-year study where there was multiple applications over the 3 years. So they do cover spring in terms of low emissions potential and summer higher emissions potential. So they're the averages for the methods. However, Harold is quite right that the potential emissions with a splash plate are a lot lower in spring. However, the potential is still higher than it would be for a low emission slurry spreading technique in spring also, because you're minimizing the surface area. So if you think about the splash plate, it splashes and covers the entire surface of the ground, and then as sun and wind bakes that out, you get more of an emission, whereas the low emission slurry spreading puts the slurry down onto the ground under the canopy potentially, and leaves it in a line which is a much smaller surface area.
Okay, and another question there, does the time of day you sprayed make any difference? And can you reduce the level of slurry being delivered by the spreader, and is this of any benefit? Well, I'm quite sure the second part.
The time of day does make a difference. So if you're spreading in the morning, so 10 or 11 o'clock, going into the peak of the day in terms of sunshine, etc., you're going to increase emissions. However, if you were to spread in the evening, where it's dull, less sun, etc., you would have lower emissions potential. So the options there in terms of the spreader, one is rate, but the other one is dilution, as Mark has quite elegantly demonstrated there. Dilution means that you have better infiltration of the slurry. It's not stuck on the surface. It'll actually move into the soil when it's more dilute, and you increase the nitrogen use efficiency.
A question here for Mark in relation to the compaction risks associated with trailing shoe and I suppose larger tankers in general being used on the land. Has there been any work or is there any impact that you've observed from these types of systems?
Yeah, it is heavier equipment, Mark, and I suppose you're trying to pick your opportunities. You're trying to make sure that land is in good condition to reduce the risk of soil compaction. Yes, there was work done in Johnstown Castle, David. I know there was a study done there by, was it Sarah Bureau?
Yeah.
Can you give us any insight to that,
yeah,
David?
So basically that showed that with heavy slurry equipment, that the soil moisture deficit, so the moisture level of the soil, was the big factor leading to compaction risk. So when the soil moisture deficit was at or near saturated, the risk was much higher, which stands to reason. It's very logical, compared with when the soil moisture deficit was below 10 millimeters. So when the soil is drying out, hitting a soil moisture deficit of below 10 meters, Met Éireann publish soil moisture deficits in terms of their forecasts and that kind of thing regionally.
How often is that published, David?
What's that?
How often is that soil moisture?
Weekly. It's if you look up Met Éireann, you'll see that the current moisture deficits, especially here in my area of the country in the southeast, are growing, and we're going to hit probably 60 millimeters of a deficit this weekend if we don't get rain. So again, getting very.
There was, yeah, Pat, go ahead there.
Yeah, no, it's a question in relation to, I suppose, dribble bar in particular, and in dry conditions, leaving lines and trails of slurry and dealing with this issue. Is it a significant issue, or is it something that can be dealt with?
In dry conditions, and we especially saw it in 2018, where farmers were using the dribble bar, there were lines of slurry, especially slurry that was spread prior to closing for silage with a dribble bar. That manifested itself that those lines actually dried out in the fields and caked on the surface and were present. There wasn't enough rainfall to actually wash them in and incorporate them into the soil, and they were there at mowing time for the silage harvest. So it is a little bit of a concern under dry conditions, and that's why we would be promoting earlier spreading of the majority of the slurry. There's much more opportunity there to utilize that slurry and also for it to be incorporated or infiltrate into the soil under dampish conditions.
And I suppose the corollary to that is the trailing shoe better from that perspective.
Yes, it would be. It would be. So the trailing shoe actually goes along on the soil surface, gets down below that grass where there's a little bit more moisture, Pat. So the trailing shoe does a better job and doesn't leave it in a wide band, which kind of sits semi onto the grass like the band spreader. So it would be a better piece of technology.
There's a question here about the contribution of all this to our overall requirement and target to reduce ammonia nationally. We might just comment on the targets that we have and how this can contribute.
Okay, so in terms of the targets, as I've said, our ammonia targets are 1% reduction up to 2030, but then the big reduction is needed. It's a 5% reduction. That's a big challenge because the 5% reduction largely has to be met by agriculture for ammonia. So as I've said in my presentation, slurry and slurry management, be it spreading, storage or housing, accounts for almost 3/4 of the ammonia emissions. So again, that's very, very significant that we get better management, reduce volatilization, spring spreading, low emission slurry spreading, amending in the houses, covering slurry stores. So those technologies are all there on the cards. In terms of greenhouse gas emissions, we have roughly a 10 to 15% reduction to meet for agriculture. It's a 30% reduction overall for nationally, but agriculture's reduction our proportion is slightly less in that. Nitrogen and nitrogen use efficiency is one of the key things here. Obviously, we have livestock producing methane, but in terms of the nitrous oxide, and the nitrous oxide being the most potent greenhouse gas, 298 times CO2, it's really, really important that we manage our nitrogen to maximize the efficiency. That's good for the business as well, because fertilizers represent a significant cost, variable cost in the business. So these technologies are really, really important there. However, the benefits can only be gotten if a farmer is doing a fertilizer plan based on soil samples. The NNP online system is there nationally for private and public advisors to use, and that will tailor the plan where there can be economies made in terms of the bagged fertilizer, the chemical fertilizer, where we don't get the savings with the low emission slurry spreading and then put on the same amount of chemical fertilizer. That's going to be an inefficiency. So we need to maximize the benefit in terms of what we keep on the ground, and then reduce our chemical fertilizer, our inputs.
Another question there, is there trial work, we mentioned biochar, but is there data or trial work done on addition of other amendments, and what kind of results are you getting from those?
Okay, so we currently have studies. Sorry?
That was just a little bit of feedback there. Go ahead, David.
So we currently have a number of studies looking at a range of different amendments. Obviously, lime and the conventional amendments are in there. Different types of manures, slurries and wastes are also in there. And then some industry byproducts. So we have a gypsum type product coming from the dairy industry. So it's a way of permeate that's been turned into a calcium sulfate, supplies both calcium and sulfur, but also has soil conditioning properties. So looking at organic matter amendments, looking at different soil conditioners in terms of limes, etc., is something that we are engaged in at the moment. Those results are not fully available yet. We don't have a full year study. They're in train at the moment, but we hope to disseminate some of that work through Mark and colleagues, through the advisory service early next year in terms of what's going on. But they are really important in terms of preserving soil quality, enhancing nutrient retention and nutrient supply. And given that we have heavier pressures on some farms in terms of stocking density and heavier machinery coming in with contractors, etc., protecting the soil and soil structure is going to be really important, and the amendments play a major role there.
Mark, we're in the month of May, we're in the middle of May now. What can farmers do now? What actions can they start taking this week? What decisions can they start making to improve the efficiency of their slurry? And is it working with their contractors?
Well, I suppose, Mark, look, I suppose first cut silage is going to be being cut as we speak, or will be cut in the next number of days or weeks. So again, I suppose it's the plan for that. I suppose look at maybe getting a contractor with a low emission slurry spreader, something like a trailing shoe. And I suppose pick your days and your conditions. As if you can get some moisture, hopefully we get rain in the next 10 days of fortnight, and try to get slurry out, look at fertilizer plan, see which fields, see what's needed there on those fields to get the slurry out, get tanks cleaned out, over the coming weeks and months. Conditions all important as well. Yeah, I suppose that's the main thing from a slurry point of view, Mark.
The reality is that if you're booking a contractor, you're not always going to get them on the day that presents the ideal conditions, can you? I mean, are there the ways to mitigate that? Or, I mean, it's I hear of farmers clubbing together to buy these trailing shoe machines and stuff like that. I don't know, have you come across that?
Yeah, that is happening in different parts of the country where, as you say, farmers are working together. They're sharing a machine, and that's a good arrangement. So again, that gives you more flexibility, in terms of when you can actually go and you can pick, I suppose, better conditions to ensure that the nitrogen is utilised and the slurry is utilised as efficiently as possible. So I think definitely we should be trying to move towards either a band spreader or a trailing shoe type of equipment, and I suppose get slurry out as soon as possible once silage is cut.
I think from speaking to Jack Nolan last week, I think the writing is on the wall in relation to the splash plate. It's probably only a matter of time by when that will be just not permitted any longer at a farm level.
There's a question there, or maybe we're being admonished for not mentioning water quality in relation to slurry spreading.
Yeah. So in terms of water quality, we are promoting earlier spring spreading, but earlier spring spreading under optimal soil conditions. So we don't want to be going out when soils are saturated. We're going to do soil compaction damage and potentially lead to the runoff of nutrients. And if there's a neighboring stream or drains or whatever, slurry nutrients may be transported towards those. So when we talk about spring application, we're talking about the second round. In a lot of cases, there may be some slurry going out very early to alleviate issues with tanks, but it doesn't all have to be spread at that point. So anytime in March, even into early April, before silage closing time, those are times of the year where we're going to maximize the benefit. There's a high demand for nutrients as we go into the onset of the major growing season. And you have weather conditions that are more conducive to reducing losses, even with the splash plate. Now, as the last question went there, is there anything that we can mitigate in terms of the technologies? The low emission slurry spreading, if you are getting a contractor and you can't specify what day he's going to turn up, he or she. So if they turn up on the day when the sun is splitting the stone, so to speak, the real good day, the low emission slurry spreading technique will help to reduce the emissions on that day, regardless of weather conditions and everything else. So what I would be saying is if your contractor has the option there of a low emission slurry spreading and you can't specify the day, that's going to maximize your return on slurry investment.
Okay, we're just coming up to 10:30 now, so I think we'll have to wrap it up. Lots and lots of questions coming through there. What we'll do is we will have a copy of all of the questions here that have been submitted, and what we'll try and do is pull together some of the key questions that we haven't had a chance to get through. Lots of interesting questions about soil biodiversity and the impact of slurry addition and so on. So, and I know there is work going on that in Teagasc as well. So look, I think what we'll have to do here is wrap things up. I want to thank Mark Plunkett and David Wall for joining us. David, I know you're not feeling particularly well today, so you're very good to dig deep for us. Pat Murphy, thank you for helping us with the questions. Yvonne Maher and Andy Boland also have been instrumental in making this series happen. also thank you to our partners who are supporting the series also. With that, I just want to thank you for listening and tuning in on a weekly basis. Next week, we will be speaking to you again, David, I think, if that's right. And we'll be speaking about, what will we be speaking about, David?
Protected urea, isn't it?
Protected urea. And Patrick Forrestal, that's right. Patrick is going to be joining us as well. So looking forward to that presentation. So with that, I wish you a good weekend. And again, the presentations will be available on the Teagasc website in the next couple of days, and the recording of the video as well will be on the Teagasc YouTube channel. So thank you very much.